What exactly is an agent? An agent runs like a simple machine. But many people miss this point, or pile on extra concepts that only scatter their attention. As an engineer, I feel I should share what I know. An agent may look complicated, but it works in a very simple way. An agent is made of a few simple parts, and countless repeated loops. These loops exist to complete tasks, and they are driven by a few main factors. 1. The model's inference. 2. The model's tools. 3. The model's harness. Let's walk through these three factors, and see how they fit together. Let's start with the most basic part of an agent, the model's inference. Every word an agent produces comes from one basic act of inference. In each inference, the input is the text you typed, plus everything output so far. For example, when you type, "the capital of China is," the model infers what the next word should be. Here, the most likely next word is, Beijing. Put together, that reads, "the capital of China is Beijing." If you rephrase the input as a question, "the capital of China is what?" the most likely next word is still, Beijing. And with that, you've completed one round of question and answer. That's it. That's model inference. Inference is the most basic part of an agent system, everything else is built around it. Once you understand inference, the whole agent system becomes much easier to understand. The way to produce longer sentences is looping. Each time the model finishes one inference, its output is thrown back into the input, and it runs again. Repeat this, and the model can write longer and longer text, until it hits a special stop token. Tools provide information beyond the input, and steer the model to handle things differently. Letting a model call tools is actually not hard. Say you ask it, "What day is it today?" We add a tool hint to the model's input. While thinking, if the model decides it needs a tool, it outputs the tool's information. Then a program we prepared in advance actually calls that tool. The tool's result is added to the input, and fed back into the next loop. In the next loop, the input contains the tool's answer, Thursday, so the model can answer. And so the model's inference changed, because its input changed. With tools, the model can take all kinds of actions. Like reading and writing files, querying the web, or calling specific interfaces for special functions. But tools alone are not enough. As we said, what the model outputs is a matter of probability, so there is always some chance of error. We need a system that checks for errors, and guards against them. That system is the harness. Take one of the simplest but most useful harness designs as an example. Much of what an agent does is modifying files, writing code, editing documents. Suppose we provide a file editing interface with only one behavior, accept the agent's modification. Then the agent will call it and modify the file directly, with no validation at all. Even if you make the model smarter, and ask it to double-check its edits, it will still get things wrong some of the time. But suppose we require edits to be made by replacement. Along with the new content, the agent must provide the content it is replacing. The tool then matches it, and when the before content does not match what is actually in the file, the edit is rejected. Now the agent can catch its own mistakes, correct them, and try the edit again. Now we have model inference as the raw power, tools as outside input, and a harness guarding the output. Time to put it all together. Start with a simple chat window. When we type something, the text plus the system's tools become the input, and it all goes to the model. Based on that input, the model decides, reply with text, or call a tool. For harder work, we let the model call as many tools as it needs, and output plenty of thinking before each action, before giving the final answer. So the system runs through many loops, until the model decides it has enough information to answer, and only then returns. And that is a basic agent system. Knowing how this works, it is easy to see why each question takes so long to answer. It also shows that the core of building an agent system is providing tools. Environment, memory, outside knowledge, they all come in as tools. Seen this way, what really distinguishes agent systems is the tools and the harness they provide. Next episode, we will build a customer support agent, and see how an agent system works in practice. If you enjoyed this, like and subscribe. Thanks for watching.